All right, what we have right here is I'm going to do part of the 2019 AP Free Response questions because you see that in number 2, we are talking about trapezoidal rule and approximation methods. And how do you do that? All right, how do you do that? And so we're going to talk about that right now. So what we're given here is a table, and the velocity, and it says the velocity of the particle p moving along the x-axis is given by a differential function v of p, where v of p of t is measured in meters per hour, and t is measured in hours. Select values of v of t as shown in the table above. Particle p is in the original position at t equaling 0. All right, we can see that right there. Boom. Now, they give us some great problems here from A to B, but what we're going to do is we are first just going to, I'm going to just be focusing on B here, on B. And what I'm going to do is it says it's use trapezoidal sums with 3 subintervals from 0 to 0.2 and 0.2 to 1.7 and 1.7 to 2.8 to approximate this value right here. All right, the value is we're going to be finding what is the area under the curve, approximate area under the curve from 0 to 2.8, and that's what an integral means. So we're going to find the area under the curve of this velocity function here. All right, meters per hour. So without further ado, how do we use trapezoidal method? Well, trapezoids are 1/2 the base, all right, or in this case, delta x times base 1 plus base 2, all right? And base 1 and base 2 are the heights. And so what we have is we're going to have a rectangle here, here, and here, indicating by this, okay? And so you want to take out your calculators, and you want to be able to solve this because you're going to have to do some little math. So the first thing is each one of these rectangles will have 1/2. And so I'm going to factor out that 1/2. Now, the second thing is that each one of these trapezoids, it's not rectangle, I think I said, all right, is now going to have a height. Now, you notice that the height between each one's changes. And not the height, but the height, or delta x changes. And so what is delta x on this first subinterval? So that is actually equivalent to the height of the trapezoid. And we realize that this height is actually going to be, well, 0.3 minus 0 is going to be 0.3. All right, so that's our first one. And now we have to multiply that by the bases. Now the bases are the heights of each one of these values. And so we have 0 plus 55. 0 plus 55. We're then going to go to the second trapezoid, And so we say, okay, what is this delta x? What is this delta x? So that's delta x1. We'll call this delta x2. All right, so our second height of our second trapezoid is we find the difference between these two values. And we realize the difference between these two values is 1.4. That wasn't too bad. Times the bases. Well, base here is we have this one. And we have this one right there. All right, because that one's used twice. And so we have 55 plus negative 29. Now, a lot of students will get confused because they'll use the one they found in the book, but they don't understand the conceptual understanding that we are actually adding different trapezoids. So some of them will just take these two values, divided by 3, and then we'll get different delta x's. So make sure you're aware that you can't just use a plug and chug formula. You gotta be a little smarter than that. Okay, well, for the final one, what is the delta x3, or our height 3 for this one? Well, we subtract those two, and what we get is 1.1. 1.1. We're going to use this one twice, and our last one once. So we have negative 29 plus 55. Boom. Nailed it. All right. Showing all this wonderful work will give you full credit. And if you want to, you can take it and put it into your calculators, all right, and find out what that value is. All right, so finishing this up, I did a quick approximation. I believe this value right here, which will be an approximation of this value right there, I probably should put approximate right there, is going to equal 40.75. 40.75. Now, what did we just find right there? Well, we found the number of meters that we're covering. All right, the number of meters we're covering. So that is the number of, that is the approximated distance or displacement traveled from 0. So we're about 40.75 meters. If you want to find the average velocity of this particle, all right, little extension problem, a little extension here. All right, sometimes you would see this on an AP test. Find the average all right, velocity, all right, average of velocity on the interval from 0 to, all right, 2.8. And what we would do is we would take this and we would have to then multiply this or divide this by uh, 2.8, 2.8. So sometimes we would have 2.8, you have the integral 0 to 2.8, all right, vp dt, and that would equal then your average. We would take our approximation right here, and so that would be approximately, we are traveling at 40.75 divided by 2.8, all right, and we have a value of about approximately, all right, 14.55, all right, miles an hour, all right, or meters per hour, okay, and that's what we have there, okay. Yeah, so this is how you would do this problem. That would be your solution. Make sure you find your trapezoids independently from each other, hopefully I did that right and you found the same values. All right, little extensions, sometimes they will put in some average velocities, but that's how you use the trapezoidal rule for finding integrals. All right, good luck and God bless in the rest of the problems.